Lesson 3.1, Parallel Lines and Transversals. So your goal is to understand the relationship between angles formed by parallel lines cut by a transversal. Specifically, we're going to take what we learned from our investigation activity and put some definition to the different angles that turn out to be congruent. So let's start off with corresponding angles. Corresponding angles are angles that occupy the same relative position at each intersection. So let's take a look at what that means. So as we discovered with our activity, when you take two parallel lines and cut them with a third line called the transversal, you get all these angles, and there's a direct relationship between certain pairs of angles. All right, so in these notes, what we want to do is we want to take a look at what we discovered in class, and we want to, I guess the best way to put it is to categorize them. So what I've done is over to the side here where you can't see, I've taken a second set of these same angles and I've cut them out. So for example, one here, I've got a piece that represents angle 1. So the first thing we're going to look at is corresponding angles. And some of the language I'm going to use goes back to the last chapter on transformations. And so one of the things we learned with transformations is that when you take an object and you slide it, and so what I'm going to do is I'm going to take angle 1, I'm going to slide it along the transversal. And we find that when you slide an object that you end up with the same congruent shape just in a different location. Well, that's what's happening here, is that if I take angle 1 and cut it out, and I slide it along the transversal, that it directly correlates with angle 3. And so in our definition, this is what we call corresponding angles. Angle 1 and angle 3, they're both, I think the best way to do this is I'll turn my page like this, that if you look here, angle 1 is the bottom left angle, and it corresponds to the bottom left angle here. And so that holds true for the other angles as well. If I take angle 2, which is right here, and again, I slide it with the translation, it's the same corresponding angle as angle 4. And so since the angles aren't changing, not only are they corresponding, but they're also congruent. So angle 1 corresponds and is congruent with angle 3, angle 2, and angle 4. And then as you can see over here, we could do the same thing with angle 5 and angle 6. Here's angle 5. If I slide it and translate it, it overlays onto 7. And if I take angle 6 and I slide it along the transversal, it corresponds and is congruent with angle 8. All right, so that's one way to denote congruent angles, is to find corresponding angles, and knowing that they're corresponding, that also makes them congruent. Vertical angles. Opposite angles made by two intersecting lines. Let's take a look at our examples from class. All right, so other angles that we found that happened to be congruent were angles that were across from each other, like for example, number 2 and number 5 here. And the way we can relate this back to transformations is think about rotations. Rotations, we did in the last chapter, was this idea that you take an object, you find a point of rotation, which is going to be this point right here, and if we rotate it 180 degrees, we notice we get the same identical congruent angle on the other side. And what we call these, angle 2 and angle 5, we call these vertical angles because they're across from each other. And so they have this relationship that they're directly across from each other, and also they are congruent. Same thing, if you look here, we've got angle 1, and if you think about rotating that 180 degrees, you would get angle 6. And so angle 1 and angle 6 are vertical angles, which makes them congruent. 3 and 8 would be vertical congruent angles, and 4 and 7 would be vertical congruent angles. Alternate interior angles. These are angles between the parallel lines, meaning in between the two parallel lines, on opposite sides of the transversal. Let's take a look at what we mean by that. Now, alternate means they're on opposite sides of the transversal. So in fact, if I put my paper like this, we'll consider this the top of the transversal and then the bottom. So these are top and bottom alternate sides. Interior means that the angles we're looking at are on the inside of the two parallel lines. So we're not concerned with 1 and 5 and 4 and 8. So a pair of alternate interior angles would be 2 because it's on the inside of the parallel lines, and then 7 because it's on the alternate or opposite side of the transversal. So 2 and 7 are alternate interior angles. 3 and 6 would also be alternate interior angles. They're on the inside of the parallel lines on opposite sides of the transversal. And what we can do is we can also show, like we saw in class, that these are also congruent, but with a series of transformations. Let's say I take 2 here. So what I could do is I could first do a translation. I could slide 2 over to here on top of 4. And then using this as my point of rotation right here, I can rotate 2 180 degrees, which puts 2 on top of 7. So by doing a translation and then a rotation, I find that 2 and 7 are congruent angles. So alternate interior angles are congruent. Let's show the same thing with 6 and 3. If I take 6 here, I do a translation on top of 8, and then I rotate it, it'll end up on top of 3. So the alternate interior angles of 3 and 6 are also congruent. Alternate exterior angles. Angles on the exterior of the parallel lines, and again, on opposite sides of the transversal. It's much like alternate interior angles, except instead of looking at opposite sides of the transversal inside the parallel lines, we're looking at them outside or external from the parallel line corridor here. So in other words, we're not looking at 2, 3, 6, and 7. We're looking at alternate sides of the transversal on the exterior of the 2 parallel lines. Okay, so alternate exterior angle pairs would be 1 and 8, because 1 is on the opposite side of 8, so alternate exterior angles. And then same thing, 4 and 5 are alternate exterior angles. And like alternate interior angles, they have the same property where if I do a combination of transformations, I can show that 1 and 8 are congruent. I can slide 1, doing a translation, on top of 3. Then I can rotate 1 so that it lands on top of 8 and show that those 2 are congruent. So alternate exterior angles are congruent. I can do the same thing with 5 and 4. If I take angle 5 and I slide it and translate it on top of 7, and then I rotate it on top 180 degrees on top of 4. So 5 and 4 are congruent alternate exterior angles. Now this is a definition that may be a repeat, but let's go over it anyways. Supplementary angles, angles that add up to 180 degrees. Now, another thing I hope you notice is the fact that when we created these different pictures, that everything was straight lines. We made our 2 parallel lines using a ruler. We made our transversal with a ruler. So even though it's kind of something we've already discussed, that should also make you realize that when we're looking at this, that we are creating a whole bunch of supplementary angles. That if I look here, this creates a perfectly straight line, 180 degrees right here, which means that 1 and 2 are supplementary. They add up to 180 degrees. I could turn my ruler and put the ruler here. Again, a straight line, which makes 2 and 6 supplementary angles. They add up to 180 degree straight angle. Okay, and pretty much anywhere on here, I can put a ruler, I can show that straight line and see these different supplementary pairs.